Welcome to my project on explosive investigations. In this presentation, I will explain the science behind explosions and discuss how forensic scientists investigate the blast scene or crime scene. Gone are the days where we have to worry about bringing a knife to a gunfight. In the 21st century, people are bringing bombs. Due to the easy access to bomb-making materials such as explosive laboratory chemicals, dynamite, and an assortment of military explosives, criminals have stepped up the game when it comes to revenge, retaliation, property destruction, and plain old mischief. The degree to which a bomb can be built is only limited by the skills and imagination of the bomb maker. Once a bomb is crafted, its use is also limited only by the mind of its creator. With the media attention on the war against terrorism, most people may assume that a terrorist organization is responsible for a bomb detonation. Contrary to common belief, most bombs in the United States are detonated by individuals with homemade bombs used in property destruction. Explosions like fire are the result of combustion accompanied by heat and gas. The key difference in an explosion is the rapid rate of the reaction. An instant buildup of gas pressure at the origin of the explosion produces violent physical disruption to its surroundings. An explosion undergoes a rapid exothermic oxidation reaction that produces large quantities of gas. The sudden buildup of gas pressure is involved in an explosion. Detonation occurs so rapidly that oxygen in the air is unable to participate in the reaction, and therefore many explosives must have their own source of oxygen, an oxidizing agent. These agents can be found in substance called black powder. Black powder is a low explosive that is composed of a mixture of potassium nitrate, charcoal, and sulfur. Some explosives, or high explosives, have their own oxygen and fuel components combined in one molecule. An example of this is nitroglycerin, the major ingredient of dynamite. Nitroglycerin combines carbon, hydrogen, nitrogen, and oxygen. When nitroglycerin detonates, large quantities of energy are released as the molecule decomposes and the oxygen recombines to produce large volumes of carbon dioxide, nitrogen, and water. Explosives are typed by the speed at which they decompose and are considered either high or low explosives. In low explosives, speed is called the speed of deflagration, or the speed of burning. Deflagration is characterized by very rapid heat, light, and subsonic pressure waves. Explosions. When nitrogen detonates, large quantities of energy are released as the molecule decomposes and the oxygen recombines to produce large volumes of carbon dioxide, nitrogen, and water. Explosions are typed by the speed at which they decompose and are considered either high or low explosives. Low explosives, speed is called the speed of deflagration, or the speed of burning. Deflagration is characterized by very rapid heat, light, and subsonic pressure waves. High explosives are typed as the speed of detonation, which refers to the creation of supersonic shock waves within the explosive charge. The shock wave breaks the chemical bonds of the explosive charge, leading to the new instantaneous buildup of heat and gases. Low explosives decompose relatively slowly at rates of over 1.5 miles per second or 1,000 meters per second. These slow rates create propelling or throwing actions and are ideal for discharging ammunition or launching skyrockets. The most common low explosive is black powder or smokeless powder, both of which can be purchased very easily at a gun store and combined with over-the-counter materials such as household products. These explosives can be misused and are very dangerous. When placed in a small container, these low explosives can explode with the force as lethal as any other known explosive. High explosives include dynamite, TNT, PETN, and RDX. They can detonate almost instantaneously at rates over 5 miles per second, or 8,000 meters per second, producing a smashing or shattering effect on their target. Classified in two groups, high explosives can be either primary or secondary explosives. Primary explosives are ultra-sensitive to heat, shock, and friction and must be handled very delicately. Even under normal conditions, they detonate violently instead of burning. They are called primers because they are usually used to detonate other explosives via chain reaction. Even secondary explosives are relatively insensitive to heat, shock, or friction, and they normally burn rather than detonate when ignited. Secondary explosives are commonly used in commercial and military blasting. Most common are dynamite, TNT, RDX. If an unauthorized explosion takes place, an investigation ensues. Bomb investigation requires the cooperation of highly specialized individuals, trained and experienced bomb disposal teams, bomb site investigators, forensic scientists, and criminal investigators must all work together to fit the pieces together to solve this complicated puzzle of an explosion. The criminalists must detect and ID explosive chemicals and recover from the crime scene and must ID the detonating mechanism. Somewhere in the midst of the rubble is undetonated residue and explosive remains from the blast site. The bomb scene investigator's skill and ability to recognize a sample from the area is crucial. The most obvious is the discovery of a crater if one exists. In a crater, all loose soil and other debris must immediately be removed from the interior of the hole and preserved for lab analysis. Objects located near the origin of the blast must also be examined for residues. Wood, insulation, rubber, and other materials are readily penetrated and often collect traces of the explosives. Non-porous objects near the blast must not be overlooked. Residue can be found on the surface of metal near the site. Material blown away from the site's origin should also be recovered because it too may retain explosive residue. The entire area must be systematically searched with great care to recover any trace material. Special care must also be taken to avoid contaminating the scene, including dressing in disposable gloves, shoe covers, and overalls. All material collected for examination by the lab must be placed in airtight sealed containers and labeled with all pertinent information. Soil and other solvent materials are best stored in metal airtight containers such as clear paint cans. All debris should be separated by the areas in which they were found. Plastic bags are not ideal and should not be used as sharp-edged objects may puncture through the sides. Once the evidence arrives at the lab, all of it is examined under a microscope for the purpose of detecting particles of unconsumed explosives. Debris and the detonating device are viewed under a low-powered stereoscopic microscope with the intent to locate particles of the explosives. A handheld device called an Ion Mobility Spectrometer, IMS, may be used in the lab or in the field to screen objects for the presence of explosives. The IMS uses a vacuum to collect explosive residue from the suspected surfaces after the surface has been wiped down with a Teflon-coated fiberglass disc. The IMS exposes substances to a beam of electrons or beta rays emitted by electroactive nickel and converted into electrically charged ions. Of course, all results need to be verified through a confirmatory test. So following microscopic examination, the recovered debris is thoroughly rinsed with isotones. Isotone quickly removes explosive residue from the debris. The isotone extract is concentrated and analyzed using Keller spot tests, thin layer chromatography, TLC, high performance liquid chromatography, HPLC, and gas chromatography and mass spectrometry. The presence of an explosive is indicated by a well-defined spot on the TLC plate corresponding to a known explosive. When sufficient quantities of explosives are recoverable, confirmatory tests may be performed by infrared spectrophotometry. Big word. But that is the conclusion of my presentation. I hope you learned a lot and you have enjoyed it. And I hope that the FBI did not come busting down my door because of all of the Google searches and things that I've done to find pictures of bombs and things of that nature. But until next time, cheers.